Okay, so let's look at section 4.3. So we're going to look at theorem 7 first. So if a is not 0, b and c are constants, then y1 equal to m to the mx is a solution of this differential equation when m equals negative b plus or minus square root of b squared minus 4ac over 2a. This is the quadratic formula here, you'll see. Okay, so let's start the proof. Okay, so we need to show then that y1 equal e to the mx is a solution of this differential equation. So let's look at the first and second derivative. So you're taking derivative of e, so it'll be itself times derivative of the top part here. So let's write y1 prime and y1 double prime here. So our y1 prime, again, it'll be derivative of e itself times derivative of mx, which is just m. And then y1 double prime would be another m times this. That'll be m squared e to the mx. Okay, so now let's plug into differential equation now. So note. Okay, so we're going to substitute our y1 double prime, y1 prime, and y1 into a differential equation up here. So our y1 double prime is the m squared e to the mx plus b times y1 prime. y1 prime is m e to the mx plus c times y1, which is e to the mx. Now notice they have, all three have e to the mx. Let's factor it out. So factoring it out, we get then, so factoring the e out, we get this then. Now we're going to assume that our y1 is a solution, so we're going to assume it equals 0. And we're going to show that forces the m to be this up here then. Okay, so note, if this is 0 here, the e to the mx is not 0. Let's note that. That implies that this part must be 0. So I'm going to note that e to the mx is not 0. So if this equals 0 here, then that implies that this quadratic part, the a m squared plus bm plus c, is 0. This is a quadratic equation in m, so we can solve it for m using the quadratic formula. So doing that, then we get, so again, note, this is a quadratic equation in m, this guy here. So we can use a quadratic formula. I'm out of space here, so let me erase a few things and we'll keep going. Okay, so we have this quadratic equation here, am squared plus bm plus c equals 0. So we're going to apply the quadratic formula, and then we'll have m then is this guy here, and that's pretty much what we're trying to show. So this proves the theorem, so we're done. Okay, so I'm going to leave it there. We'll continue with the next theorem in the next video.